Is there any harmful substance in this food? I think I'm going to send this to the scientists so they can figure it out. Our main objective is to detect heavy metal ion in food using paper chromatography, and second, to calculate retention factor, RF value, and use color spot to help distinguish between ion.
You know, there are two types of chromatography, which is paper and powder. But in this experiment, we are going to focus on paper chromatography. Paper chromatography is a type of partition chromatography, which means it separates substances based on how they distribute themselves between two liquids. In this case, the stationary phase is water trapped in the cellulose fiber of chromatography paper, and the mobile phase is a solvent that travels up the paper through capillary action.
So how did this happen?
Here's how it works. As the solvent moves upward, it carries the different components of the mixture along with it. But not all components travel the same distance. Why it happens? It depends on the polarity of each component. More polar substances tend to stick to the water in the paper and move slowly. Less polar substances are more attracted to the solvent and move further up. To measure this movement, we use the RF value or retention factor. RF value is the distance moved by compound over distance moved by solvent. This is simply the ratio of how far compound travel compared to the solvent front. It helps us to identify substances by comparing RF value with the standards.
I'm Dr. Siti RAHMAH, and I'm going to be guiding you through our experiment of detecting metal ions in food sample using paper chromatography. To detect metal ions from real food sample using paper chromatography, you first need to extract the metal ions from food sample. But you can't just pour a piece of food sample directly into chromatograph paper. Instead, you need to crush it. After that, you need to put dilute acid so that we can dissolve any metal ions. And then stir. After creating the solution, we have to filter it. And then we will get the liquid extract. The liquid that we have extracted contains metal ion. And now we have prepared 3 different chromatography paper, labeled as paper 1, paper 2, and paper 3. Using a capillary tube, we are going to be putting the extract paper on all of our chromatography paper. You may repeat this as necessary. After it's dry, place it in a chamber with distilled water as the mobile phase. Move and dry the paper again.
See, are we done? But there are nothing there.
Of course not yet, because we haven't done the last and most important step, which is developing the chromatographic paper with an eluting agent. To detect the ions that is present, we need to spray each paper with a specific reagent, which is eluting agent that reacts with the target metal ions to produce colored spots. For paper 1, we will be using potassium ferrocyanate. Meanwhile, paper 2 will be sprayed with 1% Ki solution. Lastly, we will also be using 1% Ki solution for paper 3.
Thank you, Siti, for conducting the experiment. Now, let's move on to the results.
The experiment was successfully conducted, and the presence of certain ions was detected on the chromatography paper.
Based on the results, for paper 1, when the spot was sprayed with potassium ferrocyanide, it forms the Prussian blue. This confirms the presence of ferric ion Fe3+. The RF value calculated is 0.79 as the distance moved by solute is 10.7 cm and the distance moved by solvent is 13.5 cm. Next, for paper 2. A brown spot was formed, shows the presence of copper ion Cu2+ when sprayed with 1% Ki solution. Distance traveled by solute is 12.8 cm. Over distance traveled by solvent 14.0 cm. spot was identified as lead ion Pb2+ with the yellow color when reacted with also 1% Ki solution. When the solid travel at
11.6 cm
and the solvent is 14.0 cm, the NOR value that we'll get is 0.83. When comparing these three ions, copper 2 ion is more non-polar, followed by lead 2 ion and fluid ion. Why? Because the molecules that are traveled further does not react strongly with the polar paper that are made out of cellulose, allowing non-polar substance to move further upward.
What exactly makes paper chromatography so useful? Well, for one thing, it's incredibly simple and inexpensive. Paper chromatography is a very simple and inexpensive method because it only requires basic tools such as filter paper, a beaker, and a solvent. Next, it can detect multiple metal ions at the same time. Paper chromatography allows us to separate and observe more than one metal ion in a single test. For example, we can detect iron, zinc, and possibly lead in one run by comparing their spot. Paper chromatography gives quick visual results. After the paper is developed and sprayed with a reagent, different metal ions appear as color spots, making identification fast and easy without needing digital machine. Lastly, it is environmentally friendly. Because it often uses water-based or mud solvent, paper chromatography produces less chemical waste, making it safer for students and better for the environment compared to aggressive lab method. In conclusion, the separation of metal ions in food production is essential for ensuring food safety, protecting public health, and maintaining high industry standards. Through analytical techniques like paper chromatography, scientists can identify both beneficial and harmful metal ions that may be present due to processing, packaging, or environmental contamination.
This is the list of our references. That's all from us. Thank you for watching.